So section 6.4 is binomials containing radicals. So we looked at rationalizing denominators already. We're going to apply that again today. But now, instead of having just like radical 7 in the denominator, what if I had 3 plus radical 7? Or radical 2 plus radical 3, that whole quantity in the denominator. Okay, and we're going to see what happens today. What if you just wanted to multiply two things with radicals containing them, and they happen to be binomials? Again, what's a binomial? Binomial. Expression with two terms. So x plus y is a binomial. X squared plus y is a binomial. Radical 3 plus radical 2 is a binomial. Are we clear on that? Okay, so we know our definitions? Good. Let's take a look at our quick, simple rule. Okay, when multiplying binomials containing radicals, treat as if they're regular binomials. And just simply FOIL. Okay, or double distribute. Remember, FOIL is simply an acronym for double distribution. Take a look at the first one. Try example A on your own. And please FOIL it out. Try example A on your own and FOIL it out. What do we have for part A? For part A, give me the terms. And give me them individually, and then we'll combine like terms if possible.
4 times 5 is 20. And then 4 times radical negative 3 is negative 4 times radical 3.
Okay.
And then...
That's the outer.
Yeah, and then radical 3 times 5 is plus 5 radical 3.
And then last?
Last is radical 3, that's just minus 3.
And I'm going to put radical 9, but yes, absolutely, just so we can see where that came from. So first, outer, inner, last. Remember that numbers or integers, when multiplied by a radical, they can't multiply each other. You just put it on the outside. So that's where the negative 4 root 3 comes from and the 5 root 3. Combine your middle terms, obviously. Negative 4x and positive 5x would give me how many x's, Hannah?
1.
Just simply 1. So I really just have a simple radical 3 in the middle there. This radical 9 is really 3, as Arthur said, but it's a negative 3 because of this negative sign here. So I have 20 minus 3, which is 17. Okay, again, the 20 minus the 3 gives you 17. Negative 4 root 3 and positive 5 root 3 gives you the positive 1 root 3. It's hot. Any questions on this one? Please ask. Please ask. It's just FOIL, but sometimes people get confused with when you multiply a number by a radical. So when you multiply that 4 times that negative root 3, you cannot really multiply those numbers. You just think of that as 4 times negative x. That would be negative 4x, or negative 4 radical 3. How about part B? Part B, can I get someone to go through on the board? Georgia, go ahead.
Okay, so you first do radical 2 times 3.
And I'm going to write it as, yeah.
3 radical 2.
Good.
And then I did radical 2 times 4 radical 2.
Good.
4 radical 4.
Good.
And then negative 6 times 3, negative 18.
Good.
And negative 6 times 4 radical 2, negative 24 radical 2.
Good, and then?
And then you simplify that to 3 radical 2 plus 8 minus 18 because you do the 4, and then the radical 4 is 2, so you multiply 4 by 2, yeah.
Good.
Minus 18 minus 24 radical 2.
Okay.
And simplify that to negative 21.
Are we lost? I can slow down.
Minus 10.
Take a look again. She's absolutely right. So first gave us 3 root 2. Outer gave us 4 root 4. Inner negative 18. Last negative 24 root 2. Combine the first and the last terms. They're both radical 2's. So negative 3 and positive 3 and negative 24 gives us negative 21. And then this 4 times 2 is 8. 8 minus 18 is negative 10. Okay? How about part C? Let's go back up and take a look at it. What do I have to do for part C?
Well, it's just 2 of those, so it'd be 2 radical 3 minus 4 radical 5 times 2 radical 3 minus 4 radical 5.
Yeah. Okay, remember, you're still foiling. Don't try and distribute that square because there's a sum or a difference in there. When you have a sum or a difference inside of a squared parentheses, you cannot distribute the square to each term. You have to actually FOIL them after one another, okay, or multiply them. Think about the fact that you're going to double distribute here and you're not going to square those radical terms. So it's 2 root 3 minus 4 root 5. We're going to write that twice. And when I made this problem, I just went 2, 3, 4, 5. Just realized that now. It's just going to be messy, that's all, okay? But you're going to get a lot of perfect squares if you notice. 2 root 3 times 2 root 3. Well, that's going to be 4 root 9. And as you do this, you don't have to start writing the root 9 down every time. You could simply write this as 12, right? Because it's really 4 times 3. So if you notice that the root 3 times root 3 is just 3, 3 times 4 is 12. You can write it that way. Outer is going to give me 2 times 4 is 8, and it's going to be a negative. 3 by 5 is 15, so negative 8 root 15. Inner,
Negative 8 root 15.
another negative 8 root 15. And then last,
Would be 16 root 25.
okay, and 16 times 5 is 80. Good. So that's going to carry down to 80. What about the middle terms?
Add them together.
Good. They don't cancel, right?
They don't cancel.
Good. Common mistake is say they cancel. They don't. What is it?
Negative 16 root 30.
No,
No?
you don't have to.
Like
Oh,
radicals, remember?
Yeah.
It's all right. You know what you do, Worth? Remember, think about variables. If this was negative 8x and negative 8x, it'd be negative 16x, right? You don't make it 2x. You leave it alone as x. So we have 12 and 80 is going to be 92 minus 16 root 15. I can't go any further because 15 can only be broken down into 5 and 3, which does nothing for me, right? No perfect squares. How about the last one? How about the last one? What are we going to notice?
You're right.
Can you grab that seat over there?
Oh my God.
What do we notice for the last one? Ladies, relax.
It looks like a perfect square.
Yeah. It looks like we're going to have difference of 2 perfect squares here for the last one. Let's take a look. Yeah, this is just, ready? And I'm going to highlight it. This is x minus y, x plus y. When we have x minus y, x plus y, we really just have difference of 2 squares. So let's go ahead and do that. 2 root 5, 3 root 7.
On the homework, will you have to show like the steps? Like if you just went from the last one, like if you just went from.
As long as there's a perfect square, you're simplifying. But if there are steps to show, you should show them. Like, you know, if you have the square root of 16, you could just write in the next line as 4, for sure. All right, now, what do you know about difference of 2 squares? What happens when you multiply it out? Always, always. Clark.
You're gonna get an a minus b.
Yeah, a squared. You always get a squared minus b squared. Always, always, always. And we could show that right now. Right? Let's do first. We're going to get 4 radical 25. Then outer and inner are going to cancel. From the outer part, take a look. I would really get 6 radical 35. And the inner, I would get negative 6 radical 35. Those cancel. So then I have to do the last part, which is the negative 3 root 7 and the positive 3 root 7. Give me negative 9 root 49. 4 times, this is really a 5 here, is 20. And this is 9 times 7, which is really 63. So negative 43 is our number. And it's really, really amazing to think about the fact that we started part D with radicals, and they were binomials. We ended up with just an integer. Parts A, B, and C, we still had radical terms, right, and everything. There were radical terms in parts A, B, and C. But in part D, we somehow went from a radical binomial to an integer. Let's use that knowledge to help us with this next part. Okay?
No, just go on because example 2, we're reading and I don't get it.
Okay, let's do this next part. Take a look at example A. Example A, that denominator is not rational. We need to rationalize it. We need to rationalize it. What should we multiply by? Use example D from part 1 just now. From the last one we just did, use example D to help me answer this question. I should multiply this by something over something. And I'll tell you now, it's not root 5 over root 5. Fiona. Good, over. Because now we'll see that we'll end up getting an integer, just like we did in the last one. Let's put these in parentheses to make sure we remember. Because now this is difference of two squares. So let's write this down. When you have a binomial denominator, you multiply by the binomial conjugate. That's what this thing is we're multiplying by. They are binomial conjugates, plus or minus. When you have a binomial, it should be also irrational, a binomial irrational denominator, multiply by the binomial conjugate. Okay? Over itself. Over itself. The thing that people forget is that you still need to distribute in the numerator. See that 3? That still has to get distributed. So please don't forget that. When you have an irrational binomial denominator, meaning there's a radical and it's a binomial, multiply by the binomial conjugate over itself, meaning 2 plus root 5 over 2 plus root 5. So a binomial conjugate is just the opposite sign in the middle. So x plus y and x minus y are binomial conjugates. 5 minus 3 and 5 plus 3, although they can be reduced, are technically binomial conjugates. Okay? Anything that has a difference of just a plus or a minus in the middle of them are binomial conjugates. You're going to see that again with imaginary numbers when we get to that, which is coming soon. 2 sections. Distribute the numerator. Take the 3, distribute it please to both. We're going to get 6 plus 3 root 5. Okay, again, distribute the numerator. Don't forget that, because the next one you're going to see that you clearly must do that. Denominator, it's difference of two squares. So just do first and last. You don't have to do the outer and the inner because they're going to cancel as we saw. First will give me 2 times 2, which is 4. Last is going to be minus root 25. Again, the inner and the outer part of FOIL don't matter when you're using difference of two squares. The numerator remains the same. There's no like terms to combine. The denominator just becomes 4 minus 5, which is just negative 1. Okay, 4 minus 5 is just simply that negative 1. So how do I write this? Let's write it as not as a fraction. Okay, divide both things by negative 1. So negative 6 minus 3 root 5. Minus 3 root 5. So for parts B and C, I'm going to record today. It's the same process, but you need to remember, take a look at part B. You're going to multiply by 6 minus root 3, right? Over 6 minus root 3. Always the denominator's binomial conjugate. But don't forget, in the numerator, you need to FOIL this. I will record the rest of this video of my own, and you'll see the posting on Moodle. Okay, make sure you do the homework tonight. Well, let's do this, folks. Do the problem set tonight. I'll make this homework due Friday, but you have to do this part of the problem set anyway. So finish your problem set up tonight because it's due tomorrow. We'll make the homework from this section due on Friday when you come in for your test. Okay? 5, 5, 6, 1, 6, 2, 6, 3, 6, 4.